How to graph the opposite of a parent function. We're going to investigate and look for patterns. This is part of the Family of Functions series. You will need graph paper, or you can download this PDF and print it. Press pause as needed any time during this video. Let's first graph y equals the opposite of x squared. But before we do that, let's clear up some common misunderstandings. This is read the opposite of x squared. Also, this is read the opposite of 3 squared. Not negative 3 squared. That's something different. The order of operations has a square first, then take the opposite second. That means that the opposite of 3 squared is the opposite of 9, which is negative 9. To clarify that, we'll use a graphing calculator. So here, if you look here, I typed in the opposite of 3 squared, and I got the opposite of 9, which is negative 9. A second way is I could store 3 in for x, and then type in, well, here's x, 3, and then type in the opposite of x squared and see that you get negative 9. So these are different. The opposite of 3 squared is negative 9. The quantity of negative 3 squared is positive 9. Very easy to get mixed up. So you can see that these are not equal, and so we know that these are not equal. This is the quantity of negative 3 squared, which is positive 9. Very different from what we were asked, the opposite of 3 squared. Okay, let's go back now. So to do this, we're going to create a table. We'll use these 7 values for x. And according to our equation, y is the opposite of whatever x is squared. So the opposite of 3 squared is going to be negative 9. So we'll plot 3 comma negative 9. When x is 2, it's the opposite of 2 squared, which is negative 4. We'll plot 2, negative 4. So go ahead and finish this table and plot the points. Press pause to do so, and then resume when you're ready. So completing the table, it's going to be 1 comma negative 1. The origin remains intact. Now, when x is negative 1, the opposite of negative 1 squared, negative 1, the quantity squared, is positive 1, but its opposite is negative 1. We don't take the opposite of negative 1 and square it. We square it and then take the opposite. Different order. When x is negative 2, we get y is negative 4. And when x is negative 3, we get y is negative 9. Connecting the points, we get a parabola, but it's opening downwards. So let's compare the graphs of the parent function and its opposite, and see if we can just quickly graph one by knowing the graph of the other. We're looking for patterns. So here's our parent function, y equals x squared, and here is its opposite, and you can see they are related in some way. And so I'm going to look at these 2 corresponding points. They have the same x coordinate, but a different or opposite y coordinates. Then I'm going to look at these 2 points and look at those coordinates. And these 2 points and these coordinates. And you can pause the video at any time if I'm going too fast. So I'm looking at points and their coordinates, and hopefully you're seeing patterns here. So it's time to notice those patterns. So what do you notice about the corresponding points' x coordinates? Think about it. The x coordinates are equal corresponding points that I had there. What do you notice about the corresponding points' y coordinates? Think about it. And we saw that the y coordinates are opposites of each other. So the x coordinates are equal, the y coordinates are opposites of each other. When this occurs, we also say that these two graphs are reflections about the x-axis. So here's the x-axis here in dotted red. And you can see these curves are reflections, meaning they're like mirror images of each other, using the x-axis as the mirror. We also say that these two graphs are symmetric about the x-axis. That's another way of phrasing this. And we're going to use these properties to graph the opposite of other parent functions. So using technology, we're going to quickly look at some graphs of parent functions and graphs of their opposites. And we're also going to include tables and the graph of the x-axis to look for patterns. So here we have the graph of y equals the absolute value of x in dashed blue, its opposite in green, and we also have the table in blue here is the absolute value table in green, and they have the same x coordinates. Okay, so you'll notice that these two graphs are reflections about the x-axis, mirror images about the x-axis, and that they have the same x coordinates but opposite y coordinates in each case, every case here. Let's go ahead and look at y equals 2 to the x and its opposite. Notice that the blue and the green are reflections of each other about that x-axis, and that the y coordinates are opposites of each other's in each case with the same x coordinate. Looking at semicircle, you can see again that the blue is a reflection about the x-axis to the green, and that the y coordinates are opposites of each other. Even when they're nasty decimal numbers, they're opposites of each other. And we'll try one more, this generic function here. Notice that they are reflections about each other using the x-axis as the mirror, and that the y coordinates are opposites of each other while the x coordinates remain the same. So to summarize, to graph the opposite of a function, you have two choices. You can reflect the graph about the x-axis, or you can keep the x coordinates the same but use opposite y coordinates. We hope you enjoy that.